I'm Stewart Watkiss. I've written some books on the Raspberry Pi, one on the Raspberry Pi and electronics, one on programming, and I've also done a 12-part series as part of the Magpie, which would have been 2023 now. But in between that, I've done literally hundreds of projects related to either Raspberry Pi or Pico. So just going to give you a bit of talk about the Pico specifically. So you're going to cover the difference between a microcontroller and a microprocessor, the different models of the Pico, Pico W's, Pico 2s, and how you can use one in an electronic circuit, looking at how you can put one on a PCB and how you can power it as well. And then show some of the example projects that I've done, both ones that I've just done for myself, ones that I've done on the Magpie magazine. So first going to look at the difference between a Raspberry Pi and a Pico and see if this works. I'm going to see if I can show you it. So that's the actual size comparison. So this is a, oh, no, it's struggling with my camera, forget. Okay, so stop. Oh. Right, ignore that. We'll forget the camera. So, so this is a Pico. Sorry, this is a Raspberry Pi Zero, and this is a Pico. And the Pico is about 2/3 the size of a Raspberry Pi Zero. And the main thing is that the Raspberry Pi Zero is a full computer, as is the rest of the Raspberry Pi models. The Pico is a microcontroller. So what is a processor and what is a microcontroller? And the obvious things aren't necessarily correct. And it's quite actually difficult to distinguish between them because, for instance, if you say performance, we all know that a computer is always faster than a microcontroller. But actually, if you compare some microprocessors, like, I mean, it's getting a bit old now, but the 6502, then actually a Pico is probably quite a bit faster than those. So not necessarily comparing apples and pears, like things there though. If we sort of look just at modern technology, rather than looking at those, I've chosen three things which I think are the main differences between a microprocessor and a microcontroller. And these are oversimplifications, but give you an idea. So microcontroller is usually used for a single purpose. You would, for instance, you could be monitoring a certain condition, and in response, you can say turn a light on or something like that. And you may have multiple sensors and multiple outputs and a bit of decision process, but it's generally about one task compared to a microprocessor or a computer where you might be running multiple tasks at the same time. Not necessarily web browsing in Office, because we use them embedded in our projects as well. But if you imagine perhaps you've got a drone and you want to manage both the speed, the propellers, its position in GPS, and record some video from a camera at the same time, you're starting to do multiple things at the same time. And that's where the computer generally comes in hand, rather than having a microcontroller. Then the microprocessor includes additional functionality. That's actually within the chip itself. The microprocessor perhaps has an I/O bus for communicating with external devices. And something like the Raspberry Pi, that includes graphics logic as well. So you can communicate directly with HDMI screens through that. The Raspberry Pi actually is a bit more of it's a system on a chip, so it's got even more functionality than just that. But the main thing isn't isn't just those. It's the fact that it's got a memory management unit generally on a microprocessor, and that whereas you don't generally on a microcontroller. And the benefit of that is that it uses virtual memory. So you have an application that you put on a microprocessor, and it will ask the memory management unit to allocate its memory, and it will talk to that memory. Whereas on the microcontroller, you're just doing all that yourself. And the MMU makes it much easier to run multiple programs through that using memory virtualization. And then the final one is that the microcontroller does not need an operating system, whereas a microcomputer generally does. But that's not to say you can't, there isn't exceptions to these rules. You can run bare code straight on a microprocessor if you want. But typically a microcontroller like a Pico, you'll write the code and it run directly on the hardware. You could use C and compile it, or use Python and then use an interpreter, which I'll explain later. Whereas on a Raspberry Pi, typically you're running a Linux operating system and it's communicating with the operating system rather than directly with the hardware. But they're the technical bits. Really, I think it gives you a better idea just looking at, well, which one's better, which one fits in which circumstances. And again, this is simplified, and there are exceptions to every one of these rules, and I've done them several ones with different ones. But to give you an idea, for instance, if you're wanting to run a graphical application on a proper screen, on a TV, on a monitor, then a Raspberry Pi is more suitable for that. But if you just put in a very simple output on an LCD display, then that's what the Pico is quite good at doing and works quite well. If you've got lots of complicated calculations or decisions, you may be using a bit of AI or anything like that, then the Raspberry Pi has that extra processing capability. Whereas a Pico works well with simple logic-based sensors, triggering outputs, making simpler decisions, and not so much complicated processing. Where the Pico starts to shine is in real time. So the Raspberry Pi, you can get real-time operating systems, but as a general rule, the Raspberry Pi, you're using Linux, and it's perhaps swapping between various different tasks at the same time. And that means you can't guarantee that it will be able to run your code at that particular moment in time. Whereas for the Pico, it's more deterministic. You write your code and you can know that it will be able to write to that output, read that input when you want it to. Assuming you write your code well. It's possible to do it, end up in loops and things like that, and that not work. But as a general rule, you've got a lot more control over that. And that can make it better if you've got something where you have to read that sensor immediately. You want an immediate response. Imagine, and I wouldn't necessarily use the Pico for this, but a microcontroller that's in a car looking after your brake system. And you want that to be able to respond in real time. The moment the sensor detects you're going to collide with something, you want that brake to apply immediately. You don't want it to say, hang on a minute, I've got to update the display on my in-car entertainment system first, and then I'll get round to you. And that's sort of the difference, is that it gives you that deterministic response. And as I mentioned before, Raspberry Pi will normally have an operating system that you would communicate with, and a Pico doesn't have an operating system. And I've put that, as a result of that, the Pico is perhaps more reliable. That in terms of when I've had a problem with a a project. Generally, if you create a project on a Pico, once it's up and running, you switch it on, it's immediately running, it's working, and it's reliable. With the Raspberry Pi or other computer-based systems, then there's always the chance that something's going to get in your way, or it's going to there's a problem with the operating system or whatever. So I find that because of there's much less code obviously on a Pico. Without that operating system, it can be, in certain circumstances, more reliable. But that was just it, just to give you a quick overview, really, of where you'd use them. And now going to move on to looking at the different models of the Pico and the Pico 2 and the different variations of those. So originally we started with a Pico. First microcontroller, I'm calling it a Pico original here, and didn't have any Wi-Fi and anything, and it came as a bare board. Just go back to the previous slide. As you can see, it comes with holes on here for connecting. It doesn't have any headers soldered onto those. And then the next iteration, they actually released two at about the same time. The Pico W adds the Wi-Fi capability, so it adds an Infineon wireless chip mounted on the board, which can support both Wi-Fi, but it also supports Bluetooth. And around the same time, they launched the Pico H, which added the headers. And generally before that, you'd have to solder the headers on yourself. And I think the idea was that if you have the headers pre-soldered, it lowers the it means that somebody can do it without having to have that electronics experience of soldering, and without having to solder headers on first. They can plug it straight onto a breadboard or connect things to it. And then they released the Pico WH, which has headers and Wi-Fi. And so they were the first four models of the original. And then these were all based around the RP2040 microcontroller, which is the first version that Raspberry Pi created, first full silicon that they designed themselves. Then they created another microcontroller called the RP2350. So the Pico was 2040, Pico 2 RP2350. The obvious things is it's faster. It's 10-15% faster clock speed. But also it added alternative RISC-V cores. So the original Pico had a Cortex, a pair of two Cortex cores, and the 2350 has two Cortex M33 cores, as well as two Hazard 3 RISC-V cores. That doesn't mean it's a 4-processor board, though. You can only use two of those cores at the same time. So you can use two of the Cortex cores, two of the RISC cores, or a combination of one of each. It's probably more relevant to advanced users, that, so I won't dwell on the advantages of or disadvantages of those. Really, it's if you're at that stage where you're trying to decide which cores you do, then you're at a much higher stage than this presentation is going to give. So, and then it added more memory. It's more SRAM, which is on the board itself, but also on the board itself. More memory. The SRAM is on the microcontroller itself inside the chip, but then the main part of the memory, and this is quite unusual for a microcontroller, is on the PCB instead of actually inside the microcontroller. and it went up from 2 megabytes on the Pico to 4 megabytes on the Pico 2. So that's a quick comparison. Really, they're mainly interchangeable, unless you really need that extra capability or the RISC-V cores on the RP2350. The chances are that either will work in your project. But when they released the microcontroller, the RP2040 and the 2350, they also made the chips available without the Pico, and various manufacturers took it on them to create other boards that use that same microcontroller. So as far as programming them is concerned, these look very much like a Pico, but as you see, physically, they don't look like a Pico. This first one, this is an Arduino RP24, Arduino Nano RP2040 Connect, and it was the first RP2040 board that I know of that had Wi-Fi on board. So this was before the Pico W came out. One major disadvantage of that is really expensive, and it was when it was released, but it brought that on before. But it has got a lot more functionality built in as well, accelerometer and things like that. And then this is an example from Pimoroni, which is the Badger 2040. They created it as a e-ink badge, and on the back is the RP2040. So you program it in the same way, and it's really low power. So now good to move on to how you can actually use it though. So you can plug it straight onto a breadboard. So I was going to switch to show the camera. You can see, let me turn off it's not going to work on that. So you can mount it straight onto a breadboard, or you can incorporate it into your own circuits. I'm just going to sort of go through some of the ways you can do that. This example here is soldered with the headers on, and it's plugged into a female header, which is soldered onto the PCB. It also has castellation edges, which means you could solder directly to the PCB without using the headers. As a hobbyist, I don't think there's much advantage to that, because if you use headers, you can take it off and use it in other projects instead. But I guess that's designed if you wanted to incorporate into a manufacture into a product. I have seen some commercial products that have done that. So I'm going to talk a little bit about how to power the Pico. I'm only going to go through a couple of configurations. I've actually created a whole video on YouTube covering everything you need to know really about power to or from the Pico. And but I'm just going to choose the most relevant part of that. So if we take a look at the Pico, and there's these 5 pins at the top, all related to the power. Pin 40 is the V-bus, also known as USB power, and that is literally connected directly to the USB socket. So if you connect to that, you are directly on that USB socket. Pin 39 is VSys, and this is actually more useful if you're wanting to power the Pico, and it will take power voltage from 1.8 to 5.5 volts. It's got quite a reasonable range, and I'll show you an example of how you can use that. Pin 38 is ground. Makes sense to use that one because it's conveniently located with the others, but you could use any of the other grounds. There's multiple ones around the board. There's a 3.3 volt enable pin. Generally, you don't use that. That's just, I think, if you want to put it into a sort of power saving mode externally. And then pin 36 is the 3.3 volt output, and you could use that one for powering your external circuits. But bear in mind, there is a maximum of 300 milliamps. There's a buck converter on there that you would overload if you tried to put too much on it. This is the internal circuitry. Not going to go into too much details. This is just taken straight from the schematics from Raspberry Pi, but it just shows you. So here's VBus. The mouse is really small on this, so maybe you can see it. VBus connects directly to that pin 1 on the USB. The VSys is through a diode, and this prevents you from backfeeding power to the USB. So hence why it's better to power generally from that rather than from the VBus pin. And then there's a buck converter followed by the 3.3 volt. So the whole of the Pico board is powered by 3.3 volts. So you could, in theory, provide power in through there, but realistically, you want to do it from that VSys, and then this will make sure you've got a stable power supply going to the microcontroller. And here's an example of a project where I've done that. So this NeoPixel string needed a 5 volt power supply, and I've used this external power supply to power the string, and then I've used my own additional diode to connect to pin 39. And this, remember, there's a diode already between the USB and that, which prevents you backfeeding to the USB. But what happens if you connect that to USB as well? You don't want that backfeed into this because that would overload the USB. So just by using that one diode, you could have it powered either from USB or from the external power, and you don't have to worry about damaging it if you only have one of them connected. And this is showing that the PCB board, you can use KiCad to design this, and there is a footprint that you can use. The only thing it's missing is the 3D image on this one, and but you can see the layout where it's soldered in. As I say, you can either solder direct with the castellation edges, or you can put female headers on and put male headers on. And as I mentioned, the power, you can see this diode here is that power diode that goes from the power supply on here and then goes to the VSys pin straight on there. So that's how this board's powered. So while we're talking about power as well, I mentioned earlier about using USB power banks, and this has been a problem with the Pi Zero as well, because they're low power. If you use a USB power bank, they tend to try and automatically switch off. You can get some that you can force to stay on, although I did just look now for the one that I've got, and it doesn't seem to be available anymore, so presumably no longer stocked. But as I say, you can use this, and because VSys has got such a wide power range, then you could just use any batteries, normal AA batteries, lithium-ion batteries, whatever you've got available or whatever's suitable for your project. And the power requirements of the Pico are quite small as well. So in this case, the whole board is powered from 19 volts actually, and it just uses a linear regulator. It's not the most efficient way, but it's such a small amount of power that it doesn't really matter. So it can be programmed using MicroPython or C++. For beginners, I'd normally recommend using Python. I find it's an easy language to learn, but perhaps even more the case with the Pico, as it's so easy to get started. There's no need to install anything on your computer, although the Thonny editor is helpful. So, to get MicroPython, first you need to download the interpreter, which is a UF2 file. You just download it from the Raspberry Pi website and put it onto the Pico. Or if you're using the Thonny editor, that can actually do it for you. So I've actually got it to open. So this is what the editor looks like. And it's got the REPL, as Simon mentioned. This is it's known as the read, evaluate, print, and loop, but it's basically a way of running commands directly onto the Pico from a shell. And you've got the editor where you can create code and then just press play, and it will upload the code and run it. And it also provides an easy way to transfer files up and down. You can download and upload files just using that. So that editor makes it quite easy to get started programming. Or if you're using C or C++, then there is a simple setup script, particularly if you're using the Raspberry Pi as for programming. And you could use VS Code IDE if you prefer, or you can also use the Arduino IDE, even if you're not using the Arduino baseboard. This will work with the other boards as well. And you just need to install through the board manager, the Pico libraries. So I'll finish off with showing some example projects that I've done. All of these are available on my website, and I'll leave the QR code at the end and the link, so if you want to go onto them. But this is one of the first ones I made when I first got the Pico, and you see it's actually connected to a Raspberry Pi, and it was more of a demonstration of how you can get the two to talk together and you can use them together. In this case, it's a simple voltmeter. It only measures up to 3.3 volts, or you could use a voltage divider to go a bit higher. But what it does is then allows the data to be transferred to the Raspberry Pi, where it can be shown on a graphical screen. And that way you can get the best of both worlds. You've got the Raspberry Pi and you've also got the Pico that's just monitoring that in real time. This is an example. This one used the Arduino RP2040, and this is controlling NeoPixels, which is the one I used that example schematic of earlier. And use this for the wireless capability, but now the Pico W has that as well. You can use this, and by being able to do this, you can create a simple web interface and access these using the web interface, which was quite a useful thing to be able to do compared to some of the earlier microcontrollers. In this case, the code is written in C++. The rest of the examples I've shown you are all in MicroPython. The main reason I wrote this in C++ is because they didn't have the software libraries for MicroPython for the Arduino at the time, so I just used C instead. But like I say, I prefer to use MicroPython. I just find it's quite a nice language to program. I said if you want graphical programs, then you probably want to use a computer rather than the Pico, but you can get small displays for the Pico. The Pico Explorer is one, and the Pico Explorer has got this display on. It's also got a small breadboard. I'm sure you'll be able to see that on the screen. Just as a bit of a way of designing things, I wrote this little space game where you fly around and avoid or shoot the asteroids. And this one is a small little tank game on the Pico display. And this one is created using vector graphics. One of the things I did when I was creating the space game is that to make it easier to program, I've actually created an actor class in the same way that Pygame 0 does. Actually show you that on the website. So basically, by creating this, it meant that I could program the Pico in the same way you would write code for Pygame 0. So I was able to port, although I had to simplify the game anyway, but was able to use that same library. So that's something that's available. Something I've done more recently is I did this as a bit of a Christmas project. It played music from my reindeer head at Christmas, and it was to create a web-based MP3 player. And this little module here is it's called DF Player Mini, which is an MP3 player, which you can talk to using serial UART communications. You just literally just plug that in, connect it to a speaker, and then use the Pico to provide a wireless interface. And I created a small web interface that you could just pick which songs you wanted to play. And then I've shown this one at a previous Raspberry Pi and Pint. This is my model railway point controller. And this has got a Pico inside, and it's used to control points on a model railway. And it gives you both this physical interface where you flick the lever to flick the points, but it also provided a web interface as well. So you can use the web interface to control that. And then show you some of the ones that are in the Magpie magazine as well. So you can get the old editions as PDF files still. The game on the left, so this is one game, the breadboard diagram, and then the view from outside is a game buzzer game. So press the buzzer first if you're playing a quiz game, and it lights up that button to say who got first. It's also, you can add your own games, so you can have reaction timers and things like that. I created a mole bop, which is not whack-a-mole at all honest. I was actually going to call it whack-a-mole, and when I was putting it in on the magazine, they said, "Oh, for copyright reasons or whatever, we don't really want to use that." Also didn't like the idea of us whacking moles inside the game, inside the magazine, and so we called it Mole Bop, and it's actually the mole that's bopping the buttons instead. So this needed this is a board which is the Pico keypad, and you mount the Pico on top of that, and then these light up, and you press the button as they light up. And I also created another game which is based around LCD display, and this is a true or false game. So you put on some true or false questions, it pops up on the screen, and then you press the green and red button to select the answers. And that's just using an LCD display connected with a I2C module on the back. And that's it. So I do have these. I was going to put them on the other camera, but it didn't work. So you can find out all these projects that I've mentioned are on my website. There's the QR code there if you want to take a screen capture of that. And yeah, so that's it. So thanks for listening. Did we have any questions or anything?
Great, thanks, Stewart. That's really good. I did have a question about I was using a Pico W, and it's just consuming a lot of power because I was driving a screen as well. Um, I know it has some sleep functions and stuff like that. Like, have you played around with those? And how do those work? Like, how do you best use them and things like that?
I haven't. So there is some sleep functions in it. You can sort of power down just the wireless side. The only one I'd looked at was that enable pin that it literally just disconnects, turns off the buck converter, so you lose all power to the board. And that's a way you could have something that externally just triggers and wakes up your board.
Stuart, I had a fast question. That was, I saw that you had shown Thonny on there, and I was wondering when you try, or I'm assuming you use VS Code with the extensions to some degree. Have you had trouble with that by any chance? I know it's relatively recent, but the problem I've been having was that with the Picos, the USB seems to have trouble at intervals, and I end up having to restart the Mac when it does. I can't get the thing back working again. It's been one of the annoying aspects that may cause me to drop back to Thonny, in fact.
So I haven't used that for some time. Are you using it for Python rather than C?
Yes. Yeah.
Yeah. So I
Python
did
only.
use it. I know there's a new version come out since because it came out and I did use that initial version, but then it got dropped from the Raspberry Pi image and then came back on a later image. So I'm guessing it's a newer image, but no, I
Yeah.
haven't
Okay.
tried that.
Yeah. I think Thonny is going to be my choice for a while.
What do I turn off screen? Oh, there we go.
So, Greg, go ahead.
Yes. What's the current wisdom on the hardware bug on the GPIO pins? There's been a lot of comment about that. I'm
So
not
there
fully up.
has. Basically, I've never seen it, and I think it's a fairly unique circumstance where it arrives. But I did look when the newer versions of the Pico came out to see if they'd updated the silicon at all, and no, they haven't. So the Pico 2W still has the same silicon as the Pico 2. For those that don't know, I think I'm trying to remember off memory, but it's a certain condition if you set an input and you pull and you draw too much current from it or something like that, and it can get in the position where it sticks at 2 volts, something like that. I did look into it at the time, can't remember the exact details, but I felt it was quite a rare condition. It's not something I would do. I would get into that position that it would trigger it from any of the projects I've done. That was my personal take on it.
Okay, thanks.
Well, what do you think about the same security headaches that they came up with?
Yeah, so my full-time job is cybersecurity. So I was yeah, just saw them recently that so the one thing I didn't actually mention is that they added the extra code, the extra security cryptographic function on the board, and yeah, they provided a bounty, and was it about 3 people, including was it two or three people managed to crack it. I think was it via power fluctuations or something like that to be able to do it, or something. It wasn't just a straightforward cracked. So.
Yeah, I think they need access to the chip, physical access to the chip, so you have to.
Yeah. So yeah, there's often things like that, and I think it's quite brave of them to open up that bounty.
It might be worth a quick mention that if people have problems with Thonny, then it can be worth trying R shell, the command line interface, MicroPython interface, as there are one or two known bugs with Thonny that R shell doesn't have.
Yeah. I've used Mu and Thonny, but yeah, as you say, you can just transfer the files manually as well and just run the REPL. All you have to do is connect via the serial port as a TTY connection or whatever to the USB port, and that'll give you the shell as well.
I'll say I've had some success with MP remote, very similar to our shell, I think.
Yeah.
I think probably the one of the biggest differences between them is in the command set. I think for me at least, it's a lot clearer what functions you're using with R shell. I think MP Remote has made some dubious choices with their command names. On the other hand, MP Remote lets you run code easily on your board without having to flash it first. So you can develop with less wear using MP Remote by doing a virtual mount onto your host's file system.
Yeah, it's not something I've tried that actually. Yeah.
Any other questions? Great, thanks very much, Stewart. That was really very informative. Just want to go back and use the Pico and more some more, especially the newer one.
Yeah.
Have you tried the risk? Have you tried the risk course? I don't know how to do those work.
So I did try it when it first came out, and I wasn't able to get it compiled. And
Yeah.